sort of programming I'm going to talk about here is often known as G-code programming. It's the most common type of CNC programming that there is, and it's common to Fanuc controls, Haas controls. Mazak controls will use this G-code type programming as well. It can run on there, and loads of controls are very, very similar to what we're teaching in this course. So it can be broken down very simply into 4 G-codes, and they're the 4 basic G-codes that you need to understand, the absolute most basic thing. And those 4 G-codes are G0, G1, G2 and G3. Now they're sometimes called, people will sometimes say G01, G00 or G02, and sometimes it's also known as G01 and G0, which is actually a misnomer. It's not actually correct. It's actually a 0. So like, for example, G1 you can write as G01 or G1. I often say G01. It's just a habit I've got into, so you'll have to excuse me if occasionally I'll just drop that in, but you can just say, well, it's actually wrong. So I'm going to talk about these 4 G-codes, and what they basically mean is G0 is a rapid command, which means the machine will move as fast as it can to a position, and G0 is just used to get somewhere effectively. So if we want to take a tool close to the workpiece, we use this rapid command, this G0 command, to get it there. And it will move all the axes together, so X, Y and Z can all move together on this, or you can move them individually depending on what you command. You can also command a 4th axis, like a rotary axis or even a 5th rotary axis. They all move together, but they don't move in a straight line, and it's important to remember that, because if you rapid X, Y and Z, it won't be like a straight trajectory, like as if you'd pulled a piece of string between the 2 points. It won't be that. It'll be whichever axis gets there first. It's a race. So if the X has got a short distance to go, it will get there, and then the Y and the Z. If they've all got the same distance to go, even if the rapids of each motor are not the same, which they probably aren't, because these motors are just going flat out, then they won't arrive together. So but you'll end up at the point that you command. So you command a point X, Y, Z, or just X, Y, but don't expect a straight line. So in other words, if there's something in the way, you could well hit it. So don't be absolutely sure that just by pulling it, if you pull a piece of string between these 2 points, that is not necessarily what you'll get. So in this component, it comes out of this hole, and I've got a rapid move to X230 and Z minus 30. But this is what you might think would happen. But that's almost like you programmed a G1, because that would be a complete straight line. If instead of G0 you had G1, that is what you would actually get. But because we've programmed a rapid move, the axes are both going to be flat out. So it's not actually going to do that. What it's going to do is the X and the Z are both going to get as far as they possibly can. In other words, in a sort of 45-degree line, and then the X will finish off. So that's what you'd get. You'd get that collision at that point, because it's going to try and rapid down equal amounts. If you look at this diagram, you can see what actually happens. The X and the Z both quickly get to that point there, and then the X has got another 200 millimeters left to go, because they would both move sort of as if you'd programmed X30 and Z minus 30. But that's only a rough move, because these motors are not identical. But that's roughly what would happen. Then you'd get this X move. So the truth of it is, the best way to program this would be to program X and then Z, and then you'll know that you're not going to have a problem. So as is the case in all my training courses, I like to show by example. In other words, I like to actually run programs, things that you can actually see going. And you know that if you copy any of the code that I'm using, it will actually work. I'm not just writing it on a bit of paper or whatever, or on a computer screen and just imagining that it actually works. So what I'm going to do here is just demonstrate these different ways that you can move using these G-codes. Now, I'm not going to explain every G-code that's here because that's not the objective of this part of the course. All I'm telling you is that we've got 4 G-codes, and I'm going to tell you what these 4 G-codes do. And really, you can program anything with these 4 G-codes. So if we first look at G0, I'm going to single block this program through, and I've got my tool in the spindle. So you can see that G0 commanded there. And that stays in. So once it sees that G0, it knows it's in rapid, and it will stay in rapid until we tell it something else. If we give it a G1, it would take the place of that G0 and it would change. But we've got that G0, so all these subsequent moves will be rapid. I'm going to move to a position, but I'm going to move X, Y and Z all at once. I'm going to go to 0 in X and Y, and I'm going to go to Z3. Now my datum is the top of this job, so I should arrive 3 millimeters above the job. Now I'm going to slow my rapid down so that you can see what it does, and you'll see that if I just enlarge that a bit, you'll see that this tool's coming in and it's moving all the axes together, and it's going to arrive at that point. Now some people find that 3-axis move a bit scary and they don't like it, but it is the quickest way to get there. So it is what you should be using. It is best practice. But some people would say, well, I don't really want that happening because I'm going to panic if it starts to get close to the job and all these axes are moving together. But it's a matter of choice at the end of the day. And then I'm going to start my spindle up and I'm going to put my coolant on. And then I'm going to do some rapid moves now. So I'm rapid in to X150 and Y150. So both axes move together. But as I said, it would be a straight line in this case because they're moving the same amount from 0. But you can't guarantee that. Now I'm just moving X. So I'm saying X minus 150. So it's not moving the Y. I'm not programming a Y move. I don't need to because it's not moving Y. You could repeat the Y, but I definitely don't recommend that you do. You just put in the axis that you move. This is just stupid. I mean, it's not of any, it's not actually doing anything. It's just rapiding around. I'm just showing you. And then I'm going to rapid back to 0. There. And there. And now if I'm just going to reset this, and I'm going to do it at full rapid now, 100%. I've changed my rapid to 100%, and first thing I do on all my programs is just take the tool up in the air so I don't have to worry. And then I've picked up my tool, and this is it, and this is fairly typical of what you would see. Bang, it's really quick coming in. So if you hit something, you won't get it. You need to knock that rapid right down and follow it, watch it through. Start my spindle, rapid, rapid, rapid. So obviously this is going to vary from machine to machine because all the rapids are different, but try and get used to the fact that it can be really, really quick. On older machines you might be able to stop it. So that's a rapid move. It's a G0 or G00, sometimes known as GO. Some people remember it by saying go because it looks like go. That's all right with me if that's what you want to say. But do not get the letter O and the number 0 mixed up because they're not the same thing. Letter O is used for a program number and the number 0 is a rapid move. So that's my rapid